Okay, now we got a little bit of some mix here. Now we're going to learn how to use the chain rule along with product and quotient rules. So now we're combining some stuff. So this will get interesting. Let's go to the next. Okay, this one's just a basic chain rule problem. But what we want to do first here is we want to write it so that it's in an exponent form. And so that little 3 in the crack, that's like saying x squared minus 1 to some fraction over 3. And that 2 there, that's what's going to go on top. And so now we can use the power rule, but we are going to want to do our u substitution first. And so we have y equals u to the 2/3. Therefore dy equals 2/3 to the u to the negative 1/3 times du. Now we got to figure out what du is. That's easy. It's just 2x dx, and let's plug it all in. So dy equals 2/3, my u again is x squared minus 1. I have a negative 1/3, and my du is 2x dx. And maybe at this point I don't even write the dx. I know what I'm going to do with it. I'm going to put it back over here. Just developing some little habits here to help us understand how to do these types of problems. Alright, well this can be cleaned up a little bit. So I have a 2x and a 2, so that's like having a 4x on top and a 3 on bottom. And this negative 1/3, isn't that like saying the cube root in the denominator of x squared minus 1? And so you get something like that. A little nasty, but it's the derivative nonetheless. Okay, why don't you try this next one on your own? I know there's not a lot of space down here, but just give it a try. So, and then I'm going to explain how to do it the easy way. Okay, hopefully you've tried it. What I would say that you can do here, and hopefully you saw, is you can just rewrite this as one thing. Instead of it being a quotient, you can rewrite this as just one power. This is really negative 7 times 2x minus 3 to the negative 2 power. So you make your u equal 2x minus 3. Therefore your du would be 2 dx. And so y really equals negative 7 u to the negative 2. And that's a really easy derivative. dy equals 14 u to the negative 3 du. Now, what is your u really? Your u is 2x minus 3. And that's to the negative 3. And your du is really 2 dx. And I guess I could have just gone ahead and written my dx over here, because you know that's what you're going to end up doing with it. We can clean this up. 14 times 2 is 28. And then that 2x minus 3, this 2x minus 3 to the negative 3 power, that's going to go on the bottom. So I'm just going to write 2x minus 3 cubed. And there we go. Alright, let's go to the next page. So something kind of didn't work out with the printing here. This should be up here higher, so I'm actually going to work this problem out up here. But I want you to notice something, and that is that really what we have here is a product. And so we're going to have to use the product rule. But first, let's clean it up a little bit. Can we write this as x squared times 1 minus x squared to the 1/2 power? And we can see we're going to have to use a chain rule as well as the product rule. Okay, so let's go ahead and just substitute in. I'm going to make this my u. So let's go up here. U equals 1 minus x squared. Therefore du equals negative 2x dx. We'll come back to that later. Let's rewrite our problem now. Y equals x squared times u to the 1/2. And we can actually take the derivative of this, even though it doesn't look like it. It's kind of crazy, but we can do it. The other thing that we can do here, even though we have an x squared and a u, is we can rewrite this in terms of just u to kind of make this problem a little bit easier. if you look over here, I have an x squared and I have a u. And I can get the x squared all by itself. So there's a few different ways for us to attack this. So I'm going to actually go ahead and do that just to show you this little trick because it's very helpful. So if I was to add the x squared to the other side, I'm going to just go down here. If I added x squared to both sides, I'd get x squared plus u equals 1. And then subtract the 1, I'd end up with x squared equals 1 minus u. Interesting, because that means if x squared is 1 minus u, I could rewrite it here as well. Right? Couldn't I replace this x squared with a 1 minus u? And then I still have this u to the 1/2. And now this is a lot simpler product rule. Again, we can take the derivative here. It's called doing it implicitly, but it's just going to get real nasty. So if we can get it all in the same term, that's going to be the easiest way. That's why I did this. So let's do the derivative now. It's going to be the derivative of the first, which is really just -1, times the second, which is u to the 1/2, plus the first, which is 1 minus u, times the derivative of the second, and the 1/2 one is one you should be familiar with. It's always just 1 over 2, and then square root u. And we should be able to just kind of clean this up now. The u, remember, is 1 minus x squared, so this is just like a negative square root 1 minus x squared, because that 1/2 really is just a square root, plus this 1 minus u can go on top, so this is like a 1 minus x squared, so you're going to see that's going to simplify, and 2 square root 1 minus x squared. Okay, if I distribute this negative, we can turn this into a positive. This becomes negative, this becomes positive. And so we're left with, I'm going to zoom in so I have some more space here. We're left with y prime equals negative square root 1 minus x squared plus, remember I have a positive 1 and a negative 1 up there, so that turns into 0, and then I had a negative x squared, so that's just an x squared over 2 times the square root of 1 minus x squared. And what you might have to do sometimes is you might have to get common denominators, and that's not that bad. It's very doable. In fact, that's going to be the simplest solution here. So to get common denominators, I'm just going to multiply this thing by the denominator on the right. So that would be 2 square root 1 minus x squared, and then a 2 square root 1 minus x squared on the bottom. Okay, I know it's getting a little crazy, but we got it. We can do this. So on the bottom, I have a 2 square root 1 minus x squared, because now I have common denominators. On the top, I have a negative times a 2 on the outside, so I'm just going to go ahead and write that. That's -2. And then I have the square root of 1 minus x squared times the square root of 1 minus x squared. Well, that's just 1 minus x squared. I didn't mean to go black there. Let's go back to blue. And then I also have plus x squared. Alright, this is going to simplify for us rather nicely. I know I'm running out of all kinds of space here. Okay, let's go ahead and distribute this -2. You got a -2, positive 2x squared, because a -2 times a negative creates a positive x squared, all over 2 square root 1 minus x squared. And we're almost done here. Just combine your like terms, and you got a 3x squared minus 2 over 2 square root 1 minus x squared. Okay, I'm going to call it good there. Technically, we could keep going if we were a glutton for punishment, because we could rationalize this thing, but I think we're in good shape for now. I know that was a lot of work, but these problems do tend to get a little hairy, so you just got to have a lot of space to do it. As you see, I ran out of space here, so use some scratch paper and just chug your way through it. All right, let's do the next one. This is going to be a quotient rule with a chain rule. So this is really interesting. So most of your problem is actually going to be in the u substitution, and the actual derivative is going to be relatively simple. Let me show you what I mean. we're going to replace that whole thing with a u. So I'm just going to say f of x equals u squared. And u is what we're going to be doing primarily. So u equals 3x minus 1 over x squared plus 3. All right, so the real work here comes in the du. So that's quotient rule. So that's the derivative of the top, which is just 3, times the bottom, minus the top, times the derivative of the bottom, which is 2x. And then the whole thing is over x squared plus 3 squared. One last thing here. When I took the derivative of 3x minus 1, I could have put a dx out here, and I could have put a dx out here. Instead, I'm just going to attach a dx out here. You'll see why here in a second. If you think about it, if there was a dx here and a dx here, you could factor it out and put it off to the side. Oops, it's kind of floating. Okay, so what's our derivative? Well, that's f prime of x, or you could just say dy for now, equals 2u du. So, got a lot of stuff here. We got our u, we got our du. Let's go ahead and plug it all in. dy equals 2 times my u, which is this whole thing, times my du, which I'm going to go ahead and distribute here. So I would get a 3x squared plus 9. And if I distribute this 2x and this negative at the same time, we would get a negative 2x times 3x is negative 6x squared. And a negative 2x times negative 1 is positive 2x. And that is all over x squared plus 3 squared. Now remember, there's this dx out here floating around, but now I can just go ahead and divide it by both sides. You see where it ends up. Okay. I'd like for this to be done, but the reality is it's not. This can be simplified quite a bit, and so I want us to do that. I'm gonna do my work down here though, so you can see it. Kind of draw on some borders here because it's starting to get real messy. So let's think about what we have. Let's first just think about the top. I know I have a 2 on the top because I'm multiplying. I also have a 3x minus 1. And I also have a 3x squared minus a 6x squared. That is a negative 3x squared. And I also have a 9, and I also have a 2x. So plus 2x plus 9. And on the bottom, I have an x squared plus 3 times another x squared plus 3 squared. So that's really an x squared plus 3 cubed. Okay, so I thought we could simplify it a lot more than this, and now that I think about it, I don't think that we can. So this is it. This is your derivative here. This is what it originally was f of x, so I'm just going to write it as f prime of x. But that's probably as simple as we're going to be able to get it. So pretty nasty, but still very doable problem. All right, I'll see you guys on the next one.